Alright, so we also have these two pendant lines which help support the jib by connecting further down. Of course, even without them it'd still be held in place firmly, but this just makes sure it doesn't droop down.
Good.
And not only can we trolley in and trolley out, we can also rotate the entirety of the crane. It sits on top of a lazy Susan that lets us rotate it.
Now in regular tower cranes, the swivel part is right underneath the jib.
Right about here.
Right. We'll have a video of that, but this is what we've got. And then the load line is connected, is on that windlass. When you rotate the windlass and raise and lower the load.
To lower it, just lift up the automatic brake and turn it.
Okay. Now, let's put a 1 brick counterweight on the counter jib.
Conveniently have a brick right here.
And we're going to put another brick in the skip. Okay, now take a tape measure, and now to determine the moment of the torque, we measure from the pivot point, which in this case is the outrigger.
Yep.
So take the pipe, so we have to transfer the line of force. What force are we talking about?
The force of gravity.
Okay, so the line of force lines up with the pivot point, which is right there, that outrigger, and that lines up with the left-hand blue tape, the other one. Okay, so we measure from that tape, and the tape on the trolley is the center of the load and the skip and the trolley. So measure 16 inches from those points.
Sounds good.
You may have to trolley out a bit.
For sure. There we go. That's
Okay.
16.
So 16 inches from the center line of the load to the pivot point, which is the right-hand mark. And then it's pretty stable, right? It's not about to tip over?
Nope. I could mess with it and it's pretty stable.
Okay, and I'll after this video I'll show what the numbers tell us,